Hi, these are the notes for section 2.2 in trigonometry. So this section is just should be review for you, review of basic linear functions in solving equations, things like that. So let's remind ourselves what a linear equation is. A linear equation is something that looks like this, where you have two variables, x and y, and you have numbers a and b. You could have a number on the y as well. So when I say an equation of the form, I'm not saying the equation of the form, because you can rearrange this equation. It's still considered linear. Okay. Now, all you need to remember about equations is that if you do something to one side of an equation, you must do the same thing to the other side. And as long as you follow that rule, you'll be okay with equations. So, first thing to remember is the slope of a line. If you remember the old adage, 2 points determine a line. Okay, well, if these are my 2 points, x0, y0, and x1, y1, then I can compute the slope. And this is often abbreviated with the letter m. Someone told me once that's because of French, but I've also heard that that's not true. So take that as you will. You'll see often this notation delta y over delta x. This triangle is the Greek letter delta, and it means change in. So as the change in y between these 2 points divided by the change in x between these 2 points. And when you're talking about the change of a number, then it's a question of subtracting them. Okay, so what I do is I subtract y1 minus y0 and divide that by x1 minus x0. And you may have heard this called rise over run. However you think about it, being able to compute it's all that really matters. Now, if you had done instead y0 minus y1, then you would also have to correspondingly do x0 minus x1. So as long as you start with the same point each time when you're subtracting, you'll be fine. A general linear equation, like I mentioned, is something with two variables, x and y, and in this case we have these letters a, b, c that I'll call parameters, not variables. What's the difference between a parameter and a variable? Parameter you usually think of as being fixed in place, where a variable is allowed to kind of be variable. So these parameters a, b, and c, and these variables x and y. And most generally you have something that looks like this. Now, this equation can be rearranged a few different ways. So if I solve this equation for y, I'll end up with something that looks like this. Now, notice I'm putting m here. Now, if you literally solve this equation for y, what would you get? You would get by, so if you subtract ax and divide by b, you would end up with y equals minus a over bx plus c over b. That's not what I've written here. So, when you solve this for y, and you get this coefficient of x, which in this case would be minus a over b, that's literally telling you the slope of that line, and that's why I wrote it in this form. So if I resolve this for y, I would end up here. There's another form of the equation of the line that's actually more useful, especially for those of you taking calculus later. It's called the point-slope form, and that looks like this. Now, what are these two forms? Slope-intercept form is the idea that if I knew a slope, if I knew the direction the line was going in, and I knew where that thing crossed the y-axis, then I can immediately jump to this mx plus b thing and write down the formula. But most of the time, you don't know the y-intercept, the y-coordinate of the y-intercept, and so it's kind of a special case that usually isn't useful. So the more useful is this point-slope form, and you can find this even if you're just given 2 points, because you know how to find a slope, and as long as you have a point and a slope, you can find the equation of the line. And that's the one I prefer, and that you just need to use sometimes. So let's look at some examples. So when I say plot an equation, what do I mean? I mean plot all ordered pairs, so like fill in all ordered pairs x comma y, that when plugged into this equation yield something true. So if I plugged in xy equals 1, 2, that would yield true, because y would be 2, and there's no x here. It doesn't care what x does. If I plugged in the point xy equals 5, 7, it would be false, because if I plugged in y equals 7 and under this left side, it would leave me with the sentence 7 equals 2, which is false. So when we plot this, we can just go to this website. This is called Desmos. It plots things pretty well, and it's pretty easy to use. So I just type literally what I see, y equals 2. I get this horizontal red line, and these are the shaded endpoints that satisfy this equation. So it's the ordered pairs xy with the property that when I take anything on this line and I plug it into this equation, I get a true statement. So if I took, say, this point here, this is at minus 4, 2. If I took this point, I plug its x value into this, and notice there's no x value there. It doesn't care what x does. And I plug in the y value into this, I'll get something true. That's all that is. Now, I can also plot something that looks like x equals. And so if I do x equals 5, this would be the set of points whose x coordinate is 5. And so in that sense, it doesn't care what y does. So y is, I like to think of an equation as a restriction. Y is free to do whatever it wants. And so you have this fixed x value, and the y's are going up and down. And because that's what y does, it's vertical, right? Of course, we can plot more complicated things, like y equals x. This will do it just fine. We get this nice linear function. Or y equals 5x plus 2. And to get a new line, just go below and click. And you can plot a lot of things. You can't plot infinitely many things, but you'll get more than enough plotting stuff out of this than you'll need. So plotting is easy. Now we can also input these things not of the form y equals. Desmos doesn't care. So if I do 2y plus 3x equals 1, okay, it works just fine. Now I could rearrange this and get y equals if I wanted to, but what's the point? So that's plotting. Now solving equations is a whole other matter. So solving, notice I've lost my y in this expression. There's no y in here. There's only one variable, and that's by design. Because if you think of the 4 as being a y, so if I was thinking of this 5x plus 3 function, let me erase these. If I'm thinking of this 5x plus 3 function as a y equals 5x plus 3, then what this equation is asking me to do is, find where it intersects the line y equals 4. So there's y equals 4. Here's y equals 4. And notice the intersect right here at this point, which has coordinates 0.2, 4. So, graphically, solving the equation is easy. You see it, and you say, aha, there it is. But, you won't always be able to do it graphically. So we have to be able to do it algebraically, and this is where doing the same thing to both sides of an equation comes in. So to solve it, to find the x value, I subtract 3. So again, I have to do the same thing to both sides. And I don't care if you show this level of detail in your notes, but if you could jump from here to here, that's fine. Or even if you could jump from
once again, good
here
afternoon,
to
ladies
the
and
answer.
gentlemen, and for those of you just joining us today too, once again, welcome you to JetBlue Flight 1486 with service to Boston. Once again, we do apologize for the delay this afternoon. Your aircraft is just a little late coming in from Boston. It is in the air on its way here. We're expecting it to pull up here to the gate about 30-35 minutes, right around 1 o'clock this afternoon. From the time that aircraft arrives, we just need about 30 to 35 minutes to turn it around and get you back on your way. So we're hoping to have you out by 1:38 this afternoon. We'll try to beat that time by a few minutes if we can. Estimated arrival time into Boston with the delay is right around 3:05.
So if you're able to go from this original equation down to
Once
x
again, if you have any
equals,
questions, concerns, please feel free to see me. I'd be happy to assist you. Thank you.
if you're able to go from this original equation to x equals in one step, that's great. But be aware, if you don't show me details in between and you made a mistake, then it's hard for me to give you partial credit. And this is a balance that you have to find for yourself. So the more you write down, the more partial credit I could give you. But the downside is it takes more time, and that's just a balance that you have to come to yourself. So here's another example of solving an equation. This is the ideal gas law from chemistry. PV equals nRT, and I want to solve this for R. Now, in this equation, all these letters mean something. P is the pressure, V is the volume, N is the number of moles of the gas, R is the so-called ideal gas constant, and T is the temperature. So if I want to solve this for R, well, I look at this equation and I say, well, what's keeping R from being by itself? And in this situation, it's N and T, and those are being multiplied to R. So all I have to do to undo multiplication is to do division, and I'll do that. So I'll divide both sides by the things keeping R from being by itself. That is, I'll divide by N and I'll divide by T, and you can certainly do those, one at a time if you want, or you can do them all at once. It's whatever you want. So if I do PV, as long as I do the same thing to both sides, I'm good. So I'm going to divide both sides by NT, and I'll get this relationship, this equation. And when I say simplify, I mean cancellation. So N and N will cancel here, the T and the T cancel here on the right, and that'll leave me with just the R. And in fact, that's why I chose to divide by NT in that case. So, just make sure that you're familiar with and able to do, simple manipulations like this, because they will come up in trigonometry. Now, often in mathematics we want to, write equations of lines. This could be useful in, say, a statistics course, or and definitely in Calc 1. In higher level courses. So let's remind ourselves how this works. This goes back to these forms of the line. So depending on what you know, you'll use one or the other. You can always use point slope. So, my opinion is just always use point slope, but I'll use one of each. So let's look at this one. So this wants us to write an equation of the line with slope -3 that goes through this point 0,2. Now 0,2 is a point on the y-axis, which means that they're telling us the y-intercept, because intercept just means crossing, and so the y-intercept of a curve is just where that curve crosses the y-axis. So this curve crosses the y-axis at 0,2. That's telling us in the slope-intercept form of the equation of the line, the mx plus b form, it's telling us that b is 2, and they're literally just telling us the slope. So the slope is -3. That's m. So you can immediately jump to the answer by just plugging things into the form. No problem at all. This other problem, we know that 2 points determine a line. So in this problem, I give you 2 points, 1, 2, -3, 1, and I want you to find the equation of the line that goes between them. I should say an equation of the line. There's not just one. So, how you rearrange it can make a different equation, but the form isn't so important. So all I do is I find the slope. To find the slope, I do that process I mentioned earlier. So I do the 1 minus the 2. I'll do the -3 minus 1. And you got to be very careful with negative signs here. But if we are, we'll get -1 on top and -4 on the bottom, and those minuses will cancel and give us 1/4. So therefore the slope's 1/4, and I'll use the point 1, 2. You could also use the point -3, 1, but I decided to use 1, 2, and so I just plug them into the slope, the point slope form, and I get this equation here. Now you're certainly welcome to solve for y, but it's not necessary. I will accept this as a perfectly good final answer because it is an equation of the line. And that's it for that section. The next section we'll talk about quadratic